Hey there, educator. Welcome to the show. I'm your host, Lanisha, and I'm all about helping educators make meaningful connections in math instruction. If you've ever attended one of my live professional development sessions, then you know how truly passionate I am about this teacher life. PD for the Soul is my space for providing professional development on the go, where you can take what you need and place the rest on the shelf for another day. New episodes drop every Sunday at 9 a.m. Eastern Standard Time. This is where we will dive into strategies, routines, and insights to help students build deeper understanding. And here's something new. Our monthly newsletter launches on March 1st. This will be your go-to spot for links to all resources we discuss on the podcast. I want you to have everything in one place. Plus, I'll share the books that will shape upcoming solo episodes in case you want to read along. But that's not all. The newsletter will also explore connections across domains and grade levels, because when we keep those connections at the core of our instruction, we give students the tools to make generalizations that make new concepts more accessible. So, hit subscribe, stay connected, and let's make math happen. See you in the episode. Sometimes, in an effort to prepare students for a test, we don't prepare them for anything. In today's episode, we are zeroing in on cohesive and consistent representations, and it's so timely as I reflect on this past week where my teachers and I discussed unpacking documents for our standards and what consistent tools could be utilized to maximize student outcomes. I recognize that math teachers are up against a lot. Students will enter the classroom tomorrow and will have completely forgotten what they learned today. There's actually a diagram that describes what happens after a learning experience. It's called the forgetting curve, and it was created by Ebbinghaus. There are several different variations online, but the overarching idea is that students tend to forget a lot after an hour and even more after a day has passed. We can counter this in several ways, but the way I want to focus on today and in my career for the foreseeable future is by leveraging connections. The solo episodes for the month are influenced by the Math Pact, Achieving Instructional Coherence Within and Across Grades by Bush, Karp, and Daugherty, as well as Visible Learning by Hattie, Fisher, and Frey. My goal in this series is twofold. First, I want to highlight how the language, notations, and representations that many of us brush off as insignificant are the culprits holding our students back. Second, I'd like you to make the commitment to do better, since at the conclusion of this series, you will know better. So as you listen to today's episode, I want you to reflect on the things that could be taking place in your classroom. And again, commit to do better if there are areas where you can. And then I want you to share this out with a colleague, because it ain't fun if we all can get some, right? All right, so let's jump in. Chapter 4 of the Math Pack opens with 4 comments that I like to offer some feedback on, just in case any of my listeners share these feelings. Comment number 1. I can't use concrete materials in my math class because students will depend on them and they can't use them on the test. Okay, so concrete materials are tools that we are packing students' toolboxes with that will hopefully allow them to make sense of various problems that they will encounter in the future. The problem is we aren't forthcoming enough with students. Imagine if you started a learning series and you let students know where they're going and you gave them a little bit about the pathway to get there. Students are now active participants in the journey instead of passively awaiting what's next. For example, if we are using red and yellow counters to reason about operations with integers, and we launch the experience by telling students that they've added and subtracted whole numbers in the past, and now we're going to work with their opposites. To do so, we are using these counters to help us understand what's happening in the operation so that eventually we can determine sums, differences, products, and quotients without the counters. We're letting students know where we're going. We're letting them know that they can't become dependent upon this manipulative because we're moving towards a point where they're not even going to need it. We're letting them know up front. Number 2, I have a lot of boxes of manipulatives in my classroom closet, but I have no idea about all the things that can be used for. So I've seen this a lot in the schools that I support where there are so many tools and resources that are just drawing dust in some closet somewhere, and it's unfortunate because those manipulatives are an opportunity to deeply engage your students. It is your responsibility to seek out support in using them. Ask a teacher friend, a coach, Google the names and see what videos pop up, or consult the website for tutorials. In many cases, we are so bogged down by what's happening today that we neglect to truly plan. Unpack your units with a teammate or a coach and look for opportunities to engage students in hands-on learning opportunities. Pull those manipulatives out of that dusty closet and put them to work. Number 3, my students don't want to use manipulatives. They think they are for little kids. I am willing to bet you that the feelings that those students have are a direct result of remarks made by adults. You may not have been the adult that made those statements, but somewhere along the way, an adult said, if you need them, they're there for you, use them. Frankly, we all need them. Although concrete is located at the front of the instructional model, I find that most students have more difficulty with the concrete than they do the abstract. Many students can mimic what they see their teachers do on the board. On the contrary, it takes time for students to understand concrete and representational models, not to mention work with them and use them to think about relationships, derive rules or patterns, or even find solutions. Change the way you talk about manipulatives, and students will change the way they think about them. Number 4, students don't really need to use manipulatives when they are in middle school. In the words of one of my favorite comedians, somebody done told you wrong. Kids encounter surface area in 6th grade and they struggle, in my district anyway. I believe lack of experience is the likely cause. I am currently enrolled in a K-5 geometry course, and the elementary teachers that I'm learning alongside share how, generally speaking, they don't spend a lot of time on geometry because it isn't a heavily tested domain. Now, obviously, this is a small group of teachers, and in no way do I want to apply this sample size to the entire elementary population. What I do want to consider is the possibility that this is happening more often than not. So when students enter middle school and are expected to calculate a figure's surface area, one could expect challenges, especially if their previous experiences aren't rich. So why wouldn't we want to give them the experience? You may be thinking, how would I know what their experiences are? And that's solid. Okay, that's a valid wondering. And my response to you would be that learning is a process. As a teacher, we should always want to provide low floors and high ceilings to reach all students. When encountering a new topic, think about ways to create that dynamic. With surface areas specifically, students need to work with the nets. They need to relate the nets to the solid figures they represent. They need to think about the edges and their measurements. They need to see those components up close and personal and have an opportunity to make sense of them. Otherwise, poor performance in this area will persist. Now, if you're in a situation where you feel like you have to keep teaching the same trick, the same procedure, or the same skill over and over again, it is likely that you've been teaching it with no connection or meaning. I've been having so many aha moments lately, y'all, and many of them center around the disconnect between what we know to be true as the educator, right, the perceived expert in the room, and what students have yet to learn or understand. For example, we use tape diagrams a lot in middle school, but do students understand them? If I have 2 rectangles with equivalent bases stacked on top of each other, do students understand that their lengths are the same? So no matter how many parts I make of one rectangle or the other, the total length is still the same. I don't think students understand that. And that is likely because we expect students to make connections in new areas rather than explicitly making clear the characteristics of the representations we are using. Oftentimes, when we're discussing the progression from concrete to abstract, we reference the CRA model, concrete, representational, abstract, right? But aren't they all representations of an idea or concept? The Math Pact suggests we call this progression concrete, semi-concrete, and abstract. They also emphasize the importance of truly connecting all 3. Instead of viewing the model linearly, it is best to present them simultaneously so students can create mental images. According to the authors, the mental residue helps students form robust conceptions and understand the relationships that are embedded in the representations. So let's think back to surface area in 6th grade. Imagine teaching the topic with solids that open to form nets alongside the pictures of the solids and the nets. Students make sense of the opposite sides that have congruent measures through exploration. They get a chance to experience opening and closing the figure and seeing how the sides that connect to create an edge are related. North Carolina doesn't go into the surface area formula in sixth grade, but I do think it's important for students to represent surface area using an expression because this will allow them to practice creating and evaluating expressions in preparation for work in other domains. Karp, Bush, and Daugherty share 4 general principles for successfully using concrete models. The first one says we should use the models consistently. That's a no-brainer, right? Students can't master what they haven't manipulated. Number 2, we should select concrete models or representations that clearly exemplify the abstract. Remember, the key here is connections. Number 3, we should avoid models that have distracting features. So using the two-tone counters to work with integers instead of snap cubes because students may start building things. We want students to focus on the goal, not on playing. Number 4, make the relationship explicit between the concrete material and the concept being modeled. The book provides a table of representations, considerations, and suggested options. I encourage those of you who are truly committed to doing better to check this book out. A few things that stand out to me are we overemphasize lines when describing linear relationships. Not every situation can be represented with fractional parts, yet we keep drawing that line, illustrating all points or possible solution. Context matters. Number 2, our knowledge of the nuances causes us to create shortcuts that are barriers to understanding. For example, we describe pi as 3 1400ths or 3.14 so much that students forget that this is an approximation of pi. The third aha is we aren't emphasizing the term opposite to describe negative numbers enough. I remember being at a conference and a teacher saying, I don't do that opposite stuff because it's confusing to the students. No, baby, it's confusing to you. And because you've neglected to clearly explain that subtraction is the same as adding the opposite, students struggle with integers, they struggle with substitution, and a lot of other topics where negative signs are encountered. The next takeaway is we rush to the abstract way too quickly with no concrete or semi-concrete insight. I understand the pressure of pacing is always on, but we have to commit to doing right by students. Chances are, if you planned your initial instruction with that concrete, semi-concrete, and abstract model in mind, you'd have much better exit ticket results. And over time, probably better results on your other assessments as well, because we're starting with what students truly need, okay? So planning is critical. And I know I've said this in several episodes. I've told you guys about that side of TikTok that I landed on where people were beating me down in the comments about planning. And I understand that some of that is related to the forms that people don't want to fill out whenever they're planning because they don't feel like people are looking at them. But I am urging you guys to think about planning for you. Planning is for you and for your kids. Okay? Planning isn't for your administrator. Yes, it does give them an idea of what's taking place in your class, but the plan is so that you can present that information at the highest level possible the first time around. Okay? It is not best practice to wing it because many times it's in those moments where we are flying off the cuff that we introduce things that are confusing. And you know why it's confusing? Because you haven't taken the time to thoroughly think it through. So that means you're drawing things that don't make sense. You're representing things and it doesn't make sense. You're writing things that are inaccurate. So plan, okay? Plan. Another takeaway, or actually the main takeaway that I want you guys to get from this episode is if we want students to retain what we teach and be able to apply it meaningfully, we have to commit to consistency, consistent representations, consistent language, consistent notation. When we're intentional about the tools that we use and how we use them across lessons, across classrooms, right? Across teachers, across years, we give students the gift of connection. And that's the gift that sticks. If your students are forgetting content or struggling to apply what they've learned, the issue may not be them. Okay? Again, if your students are forgetting content or struggling to apply what they've learned, it might not be them, baby. It might be the inconsistent ways that we've represented it, that we're revisiting those ideas. It may be us. But the best part about this is it's something that we can fix. Now, the fix ain't gonna happen overnight. I'm not even finna sell you that dream. And the fix won't be perfect. But if we do it intentionally and we do it together, it can be fixed. My challenge to all of you out there listening is to make the commitment to do better, because now you guys know better in 3 different areas. You know better in language, you know better in notation, and you know better in representations. Again, I'm urging you guys to check out this book. I don't get any proceeds from you checking out the book. This is just a book that I've come across in facilitating professional development that I thought was super impactful for me. And I just want to share it with all of you. So check it out, y'all. Until next time, I want you to keep making math meaningful, keep building those bridges, and as always, keep making math happen. Talk to you soon.